Hello, everyone, and welcome to Exorcism's Functional February with BobbiCodes. This is episode 3, and this is going to be fun. We're putting the fun in functional programming. So what I'm going to do is briefly go over what we did last week, and because I made a promise, and I like to keep my promises. And what was the promise? We learned, episode 1 was map and filter, the most basic building blocks of functional iteration. And last week we introduced reduce. And we explained how map and filter could be looked at as special cases of reduce. There was a great picture that I found here. Yeah, here it is. This is filter. So you have a bunch of X's in an array, and you have a predicate. Here is just a predicate function called isGood. It tests whether X is good. And we have a new array where it puts X in the new array if the predicate returns true. And let's see, is there a nice picture for map? Let's see. Yeah, so on the other hand, here is map, where you have a bunch of X's, and you have a function called X to Y, which gets run on every X, and so then we have an array of Y's. You would implement map in terms of reduce this way. So reduce is when you have kind of like a stateful pipeline, where if you have a function called add, which takes 2 arguments, the previous array and the new number to add. And we start with an initial value 0, which is the added addition, the identity property of addition. It's recommended to always provide an initial value, even though in Clojure you technically don't have to. So you could implement map in terms of reduce. And same with filter. I just thought that was a good picture to... and we did the Collatz conjecture exercise. And we examined a solution which used reduce. And there's a really cool function in Clojure called reduction, which, let me show you the documentation for it and a couple of examples here. My keyboard is acting up. I need to do one of the columns is not working very well, and I have no idea. It's probably a bad solder joint or something. Reductions is not only a really useful function, but it's useful for actually understanding how reduce works, because you can actually replace any call to reduce with reductions. And instead of just giving you the final result, basically what it does is it shows you every step and returns a lazy sequence of the intermediate values of the reduction as per reduce of the collection using the provided function. So here's some simple examples where normally we would have the most simple use of reduce would be to create a sum by using the plus function on a vector of ones, and that would return 4. So if we call reductions, it returns a lazy sequence 1, 2, 3, and 4, which is the result of every iteration. Now, this is what I promised from last time, because I remembered that I was really proud of myself. Why was I so proud of myself? Because I actually came up with a use for reductions on my own I didn't see anyone else do this, and I couldn't remember what it was. I even tried to grep my music synthesizer program because I thought it might have been in there. And turns out I should have just done a GitHub search of my entire username, because that's what I ended up doing. And I found this, which is really perfect to introduce a little surprise that I have today. Yes, I have a big surprise. And, I thought I have an asset for this. What am I talking about? I guess I don't anymore. But today we are going to be using functional programming to make music, because I finally had enough concentration that I managed to muster up to finish something that I've been wanting to do for a really long time, because I have this project here called MECCA, which is the Music Education Composition Creation Application. And, well, it's a clone of the Mario Paint Music Maker. But I have added a code editor using Psi, which is the small closure interpreter by Bach. And so this is hooked up to an interpreter, which runs the code entirely client-side. And we have an output window here. Now, I am going to link this repo, because not only did I finish it, but the app is live. So if anyone likes, you'll be able to follow along. So it's at github.com/btowerscoding/MECCA. I just put that link in the chat, and it's the MECCA music platform. And there's a live app, which is right here, which I will also post just a direct link to that in the chat. And if we go to it here, I'm going to get rid of that. And put the notes for today's stream up here. And yeah, so we have a reductions example by me. But first, okay. This is going to be our code for the official exercise of the week. Each week, we take a certain exercise on exorcism that uses concepts in functional programming and explore that exercise. But first, I'm going to just refresh the page here. And this app, this web page loads up with a little sample piece. There's no music here because I haven't evaluated it yet. There's a button here, the little closure symbol that evaluates it, and now there's also an eval button down here. And this is the data structure that is output by what we have here, which is the code for a little sample tune, which you might have heard before. It's Confusion by Rob Hubbard. A little bit, and I'll just play it here. Okay, that's nice and fast. And yeah, so what in the world was that? We had a bass line, which it's just a sequence of maps. It's kind of like the internal data format that we're using is, these are just closure maps. And, well, it's a sequence of maps. And each note gets a map. And what is a note? Well, a note has a certain time. There's a key for time. And it's a certain instrument. In other words, which one of these sounds? Yoshi. Which one of those? So that's 1 through 15 is instrument. And a pitch, which is an integer that uses the MIDI numbers. Now, the MIDI numbers it's an abstraction over the frequencies, so that instead of having to write every note as its frequency in hertz or whatever, instead we use an integer, and each integer is a semitone. Where 60 represents middle C. And so it actually doesn't matter which order the notes are in. In other words, it's not run like imperatively, like note for note. It's basically a specification, if you will, of all of the notes and what time they turn on. We don't have to worry about note off times because these are just samples of a common length. Oh, you have the kitties.
Meow, meow, meow.
As an aside, I might be getting a couple of kitties next week. I'm really excited about that. So, yeah, this isn't actually just a data structure. It's a function called base1, which takes a time and then adds the number of the beat to the time, which means we can loop it. So we actually heard it looped twice because it's base1 at beat 0 and at beat 16 is this base pat 1. And the drums are similar. Here we have a function which updates each note by increasing the time. Yeah, so here we can have, I made this pattern that just has like hard-coded times from beats 1 to 15. And it's just increasing each time by the value passed in. So then we can call drums 1, 0, and drums 1, 16, so that loops twice. Now, gliss stands for glissando, which is the organ slide, which are these cars here. I'm going to turn down the tempo a little bit because it was like kind of crazy fast. And play this again. I'll listen to what the organ does. It does it. Yeah, so that's glissando, which, so I wrote a function that takes a sequence of notes and, well, it binds, it sorts them by pitch and then reverses it. So that's like a descending arpeggio, if you will. It's like a chord, and the times are, well, it just offsets them by 1/10 of a beat. I guess that's the value that sounded right for this tempo organ slide. And yeah, so, and this is the lead that uses the glissando function. Like here we say gliss, and how many notes the slide is carried out for. And the ending note. Is that how it works? No, it takes a, yeah, so it's repeat 12. So it's repeating this note 12 times. And then glissando does the brrr. And here we have a definition called rhythm, which is just the concatenation of those three patterns, the bass, the drums, and the lead, and then we call rhythm. And in the output window, here we have all of these notes here. So there's also, it's very interesting, if I look at the code, there's a really cool use of reduce, actually, which is how I'm actually making the notes. In other words, I'm using reduce in order to generate the pitches of the notes. That's in the music namespace, which loads the samples and decodes them, and then turns each sample into a web audio API buffer source. And here we go. We have functions add semitone and subtract semitone, which take a sample rate, which is multiplied by 2 to the power of 1/12, which is 1 semitone. Or to subtract a semitone, we would just multiply it by 2 to the negative 1/12. Now, we have an increase rate function. Now, this probably could have been done in a simpler way, but this is just happens to be the way that I figured it out that works. And you know what? I can demonstrate this a little bit in the window. And so I think this is kind of cool. Because now, well, we have a live coding environment that that's live on the internet that anyone can just join in. And we have, it's also CodeMirror 6, which is the same editor that's used on the Exorcism site. And also, you know what? I have an exciting announcement that the Exorcism closure track, which I maintain, is one of 7 projects that is now being funded by Clojurists Together. It was announced last month, actually, and I didn't even notice it. You know, they stopped tweeting, but Clojurists Together. I will. This is a great organization, and I'm incredibly honored to be sponsored to work on the closure track for the next 3 months. So for the first time, I'll be able to actually devote all of my time to this. So we have news, and this was the Q1 2023 funding announcement, and these are the 7 projects. Wow, this is crazy, seeing my name with people like Martin Cavalar of Clerk and Daniel Higginbotham, who's creating the donut framework. And yeah, we're hoping that this could be a nice precedent for other language communities to sponsor the development of Exorcism tracks, because you know this is crazy. We have the closure build page. Well, every track has a build page. I'll put this in the chat too. You can replace closure with any language, and this has not even sunk in for me yet. 227,000 submissions. I actually can't fathom that this many people are using this silly little track that I built when I had COVID. It was like my quarantine project. 12,000 students. These numbers don't mean anything to me, but it just became abundantly clear how much value there is in this community. There is also, I was going to show you one other thing, but I can't remember. Anyway, that's Clojurists Together, and so there's that's really exciting news for the closure track. because honestly, the syllabus is kind of leaves. It's nice that it has one. Not all of the tracks have a learning mode or a syllabus, and so I'm proud that we have one for Clojure. But really, it's some of these exercises are just, to be honest, not very good, and it's important that I acknowledge that. So that I can make it better. In order to make it better, I need to understand, like this list exercise kind of means a lot to me because it was the first learning exercise that was made. I didn't write it, but we've gotten some feedback that really it's not exactly the best way to teach lists in Clojure. And I'm going to be using these streams as, well, dog fooding sessions, if you will. So that these lessons that I'm putting together and trying out with you are going to demonstrate how effectively we can teach functional programming concepts in Clojure to programmers who aren't necessarily don't have any experience or very little experience with functional programming. And there's also improvement of the track analysis tooling, which also approaches falls into that, so that more we'll be able to have better automated analysis and more approaches showing different ways to solve the exercises. And there's also improvements to the UI. Now, like you might have noticed that during these sessions, I haven't actually been using the online editor other than it's just a window to paste the code into. I've been solving the exercises in my own editor, which is always a good thing to do. And people are very personal about their favorite text editor. Here is the robot simulator exercise. And the reason why I do this, and actually I don't want to show that to you quite yet because we're going to solve it together. So I'm just going to delete that. It's sitting right over here anyway. And replace it with the stock. The stock exercise for robot simulator. So let's go find that. Simulator. And I already solved it, so I'll revert to exercise start. And okay, so here we have just the function skeleton. And so what is Robot Simulator? Let's see, do I want to do this? First, I still haven't kept my promise about showing the reductions example. So before we even get to Robot Simulator, how about if I do that? But I wanted to show just the kind of stuff, improvements that we're going to be making to the Clojure track in terms of the online editor UI. And what's the theme I'm using for VSCode? This is, it's called Floro Machine, and I actually have a repo for that. Let's see if... I have a repo for it, and yeah, this is amazing. It's actually, that's kind of what keeps me using VSCode because it's so, it's just so pretty. It's, and so, yeah, this theme is, it's a fork of another theme I found, and I'll paste this in the chat here. There's instructions in the README for all of the platforms, Linux, Windows, and Mac. And so, yeah, if you don't need to clone the repo or this repo or anything, but I did do a couple of little tweaks myself, which is why it's a fork of a fork. I made a couple little improvements. So in the CSS, like I think this orange highlight color. Anyway, okay, so that's the theme, and yeah, so this online editor is, well, it's really nice that we have it so that people can learn Clojure without having to install anything. But one of the biggest complaints that we got from people in the Clojure community is that there's no inline eval. Now, what is that? A lot of people probably have no idea what that means, and it's one of these things that you have to experience it, or at least see it in action to appreciate it. And really, it's what makes Clojure, in my opinion, one of the best teaching languages, because, let's see, am I connected to a REPL here? Let's see if I can evaluate something. We'll do 6, 7, and 8. Oh, yeah, cool. So that adds 6, 7, and 8. And we see the results not only in the output window, but right here, right next to the form that was evaluated. This is incredibly useful for teaching. So we could take one of the exercises that we did last week. All right, here's an example of reduce that uses well, it's an exponent function, just the simplest way you could do it, really. Today, it seems to be running really slow. I'm going to I'm going to restart my REPL. Or not. It's crashed for some reason. Well, all the more reason to just use this. So I can paste this here because here we have an online Clojure environment. So I hit. I'm not going to evaluate it without calling something because that seems to crash the page. So let's say we take 2 to the power of 3 and eval. Oh, yeah, it crashed for some reason. I'll have to figure out how to catch that exception or whatever. But, what I could do is make a note, and we can see how we can put notes in, and then so that's the code representing that note right here. So let's say we wanted to make the pitch something different, like where's my exponent function? Let's say we want the pitch to be 2 to the power of 3. So there's our exponent function, and I would say expt to 3. And I'll evaluate that, and we get that note, which is 8. That's right. Yeah. Yeah. 2 to the power of 3. Okay. And so one of the things that I want to do to the online editor for the Clojure track during the next 3 months is to implement something like this, so that this would be kind of the first milestone would just be to make a regular output window here like this. Or then after that, we could work on trying to make something in the same window. So we'll have to figure out what actually works the best. And we want it to be seamless, so that it wouldn't make the current experience any more complicated for anyone. So that's a cool use of reduce to generate an exponent. And, we could show, like I was saying, the reductions. If we change reduce to reductions, then that's not going to create an exponent. It's going to create a sequence of the steps, of the multiplication steps that were executed to create the exponent. So how would we make that into, so I'll call this something else, like exponent seq, or sequence. If that makes any sense. And so then we would say something like, we could use map. Yeah, I think so. So we'll take the output of exponent seq will be what we will map over. Now, the function that will output the map so we'll create a vector. No, we'll just create this map. Let's see, how would I do this? Might make more sense just to use for, okay, so Clojure has for, which sounds kind of like a familiar for loop, but it's not the way to think of it. In Clojure, for is a sequence comprehension, which, like other languages like Python, has list comprehensions. So it's the same idea, except that Clojure has a sequence abstraction, which works on, it works on data structures other than lists. Any any collection that can be sequenced, which could be even a string is can be operated upon as a sequence of characters. So we create a binding, which, so for each, just call it X. For each X in exponent seq, two, three, and we're going to output a map, which is a note, which will have that value of X in the sequence. And so that'll generate a lazy sequence of maps, which, yeah, that should work. And there we go. These pitches are kind of way too low. We have 2, 4, and 8. I don't even know if you would be able to hear that. That's like middle C is 60. So let's take X and just increment it by, we'll add X to 60. How about that? And now we can see these 3 notes. So we just made a chord because they're all at the same time. Let's hear what it sounds like. Sounds kind of weird, but isn't this cool? I made a thing. So yeah, I mean, I honestly think that this has so much power. For at least for other people like me, where music is sometimes the most real experience in the universe. I know I'm not the only one, but if something is a song, it makes sense to me. I mean, in a lot of cases. Something might make no sense, but if I can hear it as a sequence of notes, and all right. So reductions is really cool. And yeah, I was going to show how I think you understand how these work. I'm using reduce to increase the sample or decrease the sample rate to create whatever note. Okay, beautiful. So here's the reductions example where, let's say we want to make a scale. What would that look like? We would have a sequence of beats. And let's say we want just 8 notes is like is a good scale. And that would be the time. So we will have the time be the beat. And for each pitch, we will increase it by, well, whatever the interval of the scale is. And here I have some common ones used in Western music. Like here is the major scale, which is, the common, the familiar do, re, mi. Do, a deer. da 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 da, major scale. I thought I copied it. Apparently not. Okay. So this is the major scale, which is just a sequence of intervals. In other words, so it's increases by 2, 1, 2, 2, 2, 1. What am I talking about? So the da da da. What I'll do is, where's my eraser? The undo dog. He's a good dog. The Game Boy is a nice beepy sound. It's like a square wave. So the that's middle C, and then wait, no, actually that's not middle C. There we go. Whoops. All right, so that would be that's a major scale. So because so the first interval is 2 semitones. And the second interval is also 2 semitones. So it's da da da. That's a step of 2, each one of those, and then da, it goes da da, which is only 1 semitone difference. And so that's the major scale. Let's see, can I just undo? I think we have history. Yeah, beautiful. All right, so there's our major scale. And so how do we turn that into, well, notes? So we'll have a function called scale. And it will take, well, one of the types of scales. And, well, let me just put some of these other scales too. We have, one of my favorites is the blues scale, which is a 6-tone scale. Which is often used in blues music. Whoops. And these are the intervals. It can sound major or minor depending on which note you start with. And maybe we'll see an example of that. We have the pentatonic scale, which is really great. This says common to East Asian music, and oh yeah, that is true. Like Chinese music is pentatonic, and well, the chromatic scale is actually good to include because it's like not it. It's actually the simplest scale because it is just a scale consisting of all 12 tones, and which is just one interval of 1. So the chromatic scale is just 1. So we have a function called cycle, which we have to be a little careful with. Because it creates an infinite sequence of the repetitions of the items in the collection. And so what can you do with an infinite sequence? Well, you can't eat it. You would never be able to finish. So we use take or something. It could be anything, but so take 5 of the cycle. The cycle takes a sequence, and it cycles through them. Well, and that's a great function to use for a scale, because that's what a scale is it cycles. It's a cycle of intervals that continues conceptually forever. We could sing the scale for as long as we want, until we get into the extending into so that only your dog can hear it. So let's see how this would work. Scale will take a sequence of intervals, and we use reductions. And I did not see this anywhere. That's what it's not often that I figure something out myself. I mostly just steal other people's answers. But I'm proud that I actually didn't see this anywhere and figured it out myself, which is why it's my favorite use of the reductions function. Sometimes people talk about reductions where it's actually like the way I showed it before, as a way to understand the concept of reduce by seeing each step of the reductions along the way. But here's an actual unironic use for reductions, where we are using the plus function on the cycle of intervals, so that each one takes a starting pitch and then adds each successive interval to the preceding one to get the next note. It's or the next note down if we're making a descending scale. We'll say cycle intervals, and so that's going to operate indefinitely if we don't do anything. So how do we handle that? I actually don't know. Let's see how I did that in wherever I found it. Let me see. It was in another copy of my Mario Paint, another repo where I was trying something different. I want the one that's the actual source code. Okay, that's fine. Let's see. So I wrote a function called mode. Oh, so these are the Greek church modes. Ionian, Dorian, Phrygian. That gets into some basic music theory. Then I have the minor scale, which is the same as the major scale, but it starts on a different note. And the harmonic minor, which is the minor scale, but with a major leading tone, which adds, it kind of adds more tension, you could think of it. And my favorite scale, this is my favorite scale in the whole world, the double harmonic minor. I like it because it's symmetrical. It's a 1, 3, 1, 2. It has 2 intervals of 3 semitones, which makes a real interesting kind of like Middle Eastern sound, you could think of it. I'm going to copy this and put this here with our scales so that we have the, and so let's say I just want to hear that scale once. So we don't need to cycle it. Let's just take, we could do reductions plus, so that each time we will add it to the previous result, and I'll use an initial value of 60, which will be the note that we start with. And the double harmonic minor scale. So for each beat in the range of 8, okay, so that's going to do that. And we want the pitch to be, let's see if I can, I'm going to copy the contents of this just in case this blows up. No, it looks like I have an extra parenthesis here. Is this going to work? Yeah, it does work. Cool. So we have the output here. Can you see that? Actually, no, I think this is not fun. Not fun playing with these windows in Windows. Let's see here. There we go. That's now you can see the output. And that's our scale. Starting at, so it's a double harmonic minor scale. So what I'll do is I will just define a let binding, which lets us define local bindings. So we'll have the scale, which will be that. We also have structural editing commands, are working. So if I hold down Control, or it's Command on Mac, I believe, and use the arrow keys, that will slurp that expression into it, which saves a lot of time. So for pitch, we will use I'll use the nth function. So we'll say nth scale of the beat. So for each number of the beat, we'll use that index of the list. And it should work. See, yeah, cool. So here's our harmonic, double harmonic minor scale. Isn't that cool? And so then, well, we could demonstrate other scales. Well, yeah, there were some other useful ones here. And here are these church modes, which are kind of fun, but the regular harmonic minor. Now, how do we, I mentioned before that the major and the minor scale have the same notes. So how does that work? They're different scales, so how can they have the same intervals? And I mentioned that it's a different starting note. So if we said major, replace double harmonic minor with the major scale, and now we have that. By just starting it on a different note, it will be minor, and it will be 60. The third note of the scale is what determines the major or minor, and that's where we would start. So it would start on not 60, not 62, 64, I think. Let's see. No. Actually, no, that's not going to... how did I do it? Let's see. The minor scale is like the Aeolian mode. Okay, so check out what this mode function does, because this is useful. It lets us start on a different step of the intervals that define that scale, which is, well, that's what a mode is, which, so these are the Greek church modes. So Ionian is like the major scale. And that's, so for each of the modes, we take the major scale, and here we're taking the modulus of n and 7, because each scale has 7 notes. Yeah, it's 7, and then it repeats. Does that make sense? And then we drop that many off of the end of the sequence. Drop is like the opposite of the take function. So instead of taking so we take that many, and then we drop that many, and then concatenate them together. I think that makes sense. So if we had Ionian of mode 0, that means we're starting on, that's what N is, the starting note. So let's see what Ionian, I'll just copy all of these. And so, yeah, I think I could just paste Ionian here, and we're going to be starting at middle C again. Yep, just regular major scale. That's the Ionian mode. Then the Dorian mode is if we just played the same notes, but shifting it by one. So, and there's, I like to give examples of songs that use these modes. And Dorian is Thriller by Michael Jackson. It's, or Greensleeves. Greensleeves. Da, 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 da. Now, if Greensleeves is played properly, it's in the Dorian mode, but a lot of times, I see this is like a pet peeve of mine during the Christmas time. A lot of times we hear Greensleeves, and it's actually using the Aeolian mode when it's supposed to be in the Dorian mode. So let's hear what Dorian sounds like. Did I hit? Yeah. Let's hear that again. Now, Phrygian is also one of my favorites. It's in klezmer music, it's called Ahava Rabba, which means a great love. Yes. And it sounds like a classical Middle Eastern sound. Like, and yeah, what makes that sound like stereotypically klezmer is this first interval, which is of a semitone, which is it makes it sound kind of not Western. So that's cool. Lydian is popular in like heavy metal guitar solos. They like to do the modes are really popular in electric guitar theory, where they just sound slightly weird. Mixolydian, I don't know. This is a good scale. I like it, but I don't know any examples of Mixolydian. That's yeah. So it's like the major scale, but it has a flatted. The leading tone is like the minor scale, sort of, which is Aeolian, which one of the examples of a song that's in pure Aeolian mode is Other Side by the Red Hot Chili Peppers. You know, take it on the other side. How long? You know, that it's all in. I'm sure they could have picked so many different examples, but because it's just the minor key. Or if Greensleeves is played wrong. cool. Now, Locrian is the weirdest one. It's really not very. It's the one that's the least used of the modes. Cool. So that's. I'm actually kind of running out of time, but I think that's fine. We'll just do Robot Simulator next time, because I'm still experimenting with different ways that we can audibilize. I guess that's like the word for like visualize, but with audio. It's like the example of what is it called? Sound of sorting. Yes. When I found out about Sound of Sorting, I hated myself. Because I don't know, there's something about the idea of being able to hear algorithms, like, really fascinates me. A seizure warning. But it's a Sound of Sorting. Not like a channel. It's just I'll put that link in the chat to the 15 sorting algorithms in 6 minutes, and you can enjoy that on your own time. And I kind of made my own version of that. Which is on my GitHub. And it's just called Sort. I tried to kind of stretch the idea to make something, to push it into what I would call generative music, as opposed to just a straight up, like a faithful audibilization of something. In other words, I tried to make it musical. And so I'll put this link in here. So I have a great collection of links this week. And so this is insertion sort. And, I guess I... And so it's actually using the same Mario Paint sounds. And then I also did selection sort, which is sort of similar, and bubble sort, which the bubble sort is kind of cool. You can change the number of items. This is 96, so it's a real nice play, nice length, and it gets more dramatic as it ends, because each time and also this is optimized. In other words, as soon as it gets to the part where they're already sorted, each time it gets a little bit faster. And it's using the blues scale. All right. So that will this will conclude the stream for today, and so we'll get into Robot Simulator next week. And I'm BobbiCodes, and this has been Functional February.